Hi, welcome back to OGTC's The Road to Glasgow COP26 series, where we explore, I guess, all the issues that are surrounding energy transition as we take a big run up to COP26 in Glasgow in November 2021. So, throughout the series, we are inviting expert witnesses, if you will, to come on and talk about their topic, their deep dive into their area of expertise. And today we've got a fantastic show. We have Mike Smith, who's Chief Executive of Nexus, which is the Northeast Carbon Capture and Storage Alliance. I'll be introducing Mike in a second or two. We also have Luca Carrari, our colleague from OGTC, who is our own resident expert on everything CCUS. So I'm hoping that we get right to if you excuse the pun, the bottom of this topic, and really get into some of the detail and why it's important, so that we can come away with a great understanding about the role of CCUS as we transition our economy to become a much greener economy. So without further ado, I'm going to ask Mike. Mike, hi, how are you?
I'm very well, thank you. Thank you for having me, and thank you for the opportunity to talk a little bit about CCUS and how it can help with industrial decarbonisation.
No, that's fantastic. Thanks for coming on the show, Mike. What I'd like to do is just ask you to tell us a little bit about yourself and how you became Chief Executive of Nexus, a little bit about Nexus, and then we'll dive into a few questions and get a conversation going.
Sure, no problem at all. So yeah, as you mentioned, Nexus is the Scottish Industry Association for both CCUS and hydrogen. It's there to try and help deliver industrial decarbonisation, and I'm sure we'll talk at length about the importance of trying to decarbonise industry. It's been in existence for about a year now. We have over 40 supporters and members, and they represent collectively about 70% of the industrial emissions in Scotland. And we're there to support decarbonising projects around CCUS and hydrogen to help inform government and society around the important decisions that we have to make in this space and the sort of policies that we need to put in place. And we are leading with OGTC as a partner a program to deliver a net zero roadmap for industry in Scotland.
Sounds fantastic. I'm sure we'll come on to exploring that a little bit more in depth just shortly. I want to go back to COP26 itself. So every year, well, COP's a very special occurrence, and it's coming to Glasgow, as we've said. It's going to have a huge impact on Glasgow and Scotland and the UK. But what I'm really interested to hear from you is why do you think it's important, and what do you expect is going to happen at the COP26 in Glasgow next year?
Good question. I mean, I think why is it important? Why is it important for Britain and for Scotland? It's a fantastic opportunity for the UK at large and for Scotland in particular to show genuine leadership in this area. I think that Scotland is doing a lot and can continue to do more, and this is an opportunity for the planet to really understand what it is that we're doing here. So I think that's an important facet. In terms of what I think this particular COP will deliver, I think it's going to be an interesting one in that I don't necessarily expect to get a huge amount of movement in terms of the large scale policy. So people talk about prior COPs and they talk about the agreements that arrived during those. So I don't necessarily expect Glasgow to deliver a Paris-style agreement, which sort of a very large agreement to look at abating emissions across the planet. There are reasons for that. We can go into that if you want, but I don't necessarily believe that's going to be the case. So what the opportunity therefore that the COP has is really to start to shine a light on parts of the wider decarbonising conversation, parts of the wider climate emergency conversation that haven't been focused on necessarily in the past. And I do think that given the obligations that the UK has and has written into law to achieve net zero, The fact that that obligates the UK as a whole to really look across all sectors of the economy and society. I think it's a great opportunity for us to show areas that haven't necessarily been focused on. And a lot of the focus in previous COPs have been on things like the transportation sector, the power sector, the wider energy system. And there are other opportunities and other obligations to reach net zero.
Okay, well, that's a great way of framing COP for us. I'm keen to come back to your particular subject matter expertise, which is CCS. So, why don't you explain what CCUS is, and then why this matters to us as well?
Sure. CCUS, carbon capture, utilization, and storage. It's in essence the capturing CO2 that's emitted from various point sources, transporting that carbon to a place where it can be sequestered underground for tens of thousands, if not millions of years, and using that as a way of essentially mitigating emissions into the atmosphere. And increasingly, it's also been considered around the opportunity that has to create a much more sustainable and circular economy by, once you've captured some of that carbon, utilizing that carbon to create products that we need in society and that typically today are created from other sources that generate a lot of emissions in their own processes.
So are there any CCS projects currently happening in the UK right now?
At smaller scale, yes, there are. I think, and if you look internationally, there are some very large scale projects happening internationally. I think what we need to really demonstrate, and a great opportunity for the United Kingdom over the next 4 or 5 years, is to show that carbon capture and storage can happen at the kind of scale that starts to be impactful on the nation as a whole. And from that, provide the impetus and the inspiration to other countries to start to impact emissions on a global level. So my personal interest is the use of carbon capture and storage for industry. And there's some very good reasons for that. Industry is about 40% of our global energy demand, and it represents about 1/4 of global CO2 emissions. So it's a very large proportion of our overall emission spectrum for the planet. And that's simply industry. That's not including power. Sometimes people mix the two up. I'm simply talking about industry here. And, that roughly 8 gigatons of CO2 per year that industry emits, if we, as I feel we can do, if we switch the energy requirements for those industries to carbon neutral sources, you still have significant industries where somewhere between 20 and 60% of their emissions come from the actual industrial process itself. So a lot of people talk about the fact that if we rapidly increase the amount of renewable energy that we have on the planet, and as we are doing, and we should do, we can solve these kind of problems. And unfortunately for industry, even a limitless amount of renewable energy would not reduce significantly the industrial emissions, because the vast majority of them come from the process of making the goods that we need in society today.
There's a lot to unpack there, Mike, but I'd like to bring Luca into the conversation as well. Luca, hi, how are you?
I'm good, thank you. How are you, Stephen?
Yeah, not too bad, thanks, Luca. You're diving deep into the subject of CCS as well, Luca. What's your perspective on the importance of CCS to achieving a net zero society in the next 30 or so years?
I think it's fundamental, and not just me thinking about it. It's part of the CCC report, the Committee on Climate Change in the UK, that CCUS is not an option, but is absolutely a necessity in order to achieve net zero. And building on Mike's point, right? So CCS is a number of different things and can be applied to a number of different sectors. So industry is clearly an important one. A lot of debate has been going on in the past few years about CCS for power, seen as an excuse to keep burning fossil fuel, adding CCS instead of switching to renewables. And I agree that we shouldn't use oil and gas to burn oil and gas for energy. We should do renewables as much as we can, although we need to be careful on the pace of the transition sometimes. And some example from the blackouts in California recently are a good example of going too fast without backup power. But back to the CCUS, it is a versatile way of removing CO2 from the atmosphere. You can do it post-combustion, taken from industry and transporting and storing. You can do it pre-combustion by producing hydrogen and therefore capturing the CO2 from the production of hydrogen from methane and storing the CO2 and using that hydrogen to power up industrial or heating or transportation. And you can do it, as Mark said, for utilization, building bricks or other materials, carbon fiber potentially, from that CO2 that has been captured. And the beauty is that all these uses and applications are potentially synergic, so that they all require an infrastructure to transport and store the CO2. But once the infrastructure is there, you can have multiple usage or application of that, which is a synergic thing, as I said, that potentially reduce the cost for the whole thing. But in summary, yes, we do the CCS. Clearly, when it comes to power, what we need to do is produce power from renewables. But we still have a lot of processes that are very hard to decarbonize, and we still have a lot of CO2 in the air. We should also look at direct air capture as well, which again can be combined with the storage element in order to reduce dramatically and very rapidly the amount of CO2 in the atmosphere.
Okay. I'm interested in coming back to the whole question of industrial decarbonisation, Mike, because you mentioned that that was a particular passion of yours. So I know the oil and gas industry has been talking about CCS for the last 25, 30 years or so, but in this part of the world, there may be one or two examples that we can point to, but they're not in the UK. So why hasn't it happened yet, in your view?
I think for industrial decarbonisation, I think one of the reasons it hasn't happened yet is you actually find the situation that the places, the industrial clusters that emit lots of CO2 aren't necessarily conveniently located to then transport and store that CO2. That's some of the applications in the past around, particularly elsewhere in on the planet, around the US, Australia. There are good examples of where carbon capture and storage have been used, but they tend to have been used in things like the oil and gas sector, where they've been used to effectively enhance the amount of hydrocarbons that can be recovered. And there, the emissions effectively sit directly on top of the storage site. Because and it's far easier to capture those emissions and put them into a reservoir underground, and by the offset for that for those industries is that they then potentially get a larger amount of hydrocarbons recovered from that reservoir. So that is both potentially easier, it's logistically more simple, but also there is an opportunity to generate revenue from sequestering that carbon, because you are effectively increasing the amount of hydrocarbons that you can recover, and those hydrocarbons have a retail price. The other area where it's been used a lot in the past is effectively to abate the emissions from coal-fired plants. And again, those coal-fired plants have traditionally been located quite close to traditional coal fields and coal field rich areas. They sometimes have opportunities to store CO2 close to them. So again, they have that logistical issue, and they also are by and large being driven in those countries by direct laws that effectively are phasing out coal powered emissions, and this is the only way for those coal-fired power stations to continue. So if you look at the rest of the world, those kind of applications that have occurred, they really don't work for the UK or Europe. The applications that I think are really going to work for the UK and for Europe are taking CO2 from heavy industry that creates products that we need and will continue to need far into the future, transporting them potentially for quite some distance and storing them underground for millennia. That is more difficult. there is a significantly larger logistical issue, but also there isn't necessarily a revenue generating opportunity in that. It is effectively a waste management process. And that needs both the costs to be realistic, but also it needs the right kind of regulation and policy support from governments to encourage it.
And I think that's a very good point. Actually, probably 2 points here. One is why it's not happening already at industrial level. Well, I think part of that is due to the target. The target in the UK was to decarbonize 80% of emissions, and until that target was there, plenty of sectors thought they were in the 20% that was hard to decarbonize and the last to arrive. Now that there's no hiding anymore because the target is enshrined in law and it is 100%, so getting to net zero. So everybody has to think about, oh, well, how do I decarbonize our sector? Part of that is cost, and the risk that the decarbonization of industrial activity results in offshoring that activity. So to be competitive on international spectrum, you need to be very, very careful with the cost and protect the margins. And a lot of the decarbonization that the UK has seen in the past decades actually resulted from offshoring industrial or manufacturing elsewhere and importing back the product, because the way it is calculated, the emission based on where it is produced and not where it is consumed. So to avoid that and maintain the industrial capability and occupation and welfare in the country, and at the same time achieving net zero, now we need to look at that profoundly and making it happen, which leads to the second part of the point you raised, which is who pays for that, or the economics of it, because it is a waste management process taking the CO2. And so unless someone, an organization, makes a profit of some kind in doing that for third parties or for themselves, it's not going to happen. And I wanted to ask you, because I know that this week has been quite active. We've seen a number of reports or recommendation of papers coming out from BEIS, the government Department of Business, Energy and Industrial Strategy. And so is there anything there you see that you think that will make a change and will give an acceleration in terms of business model or commercial frameworks on how we can create a market for capturing, transporting, and storing CO2 that is not there yet?
So I think the reports that have come out this week and the reply to the consultation process that was been taking place for roughly the last year with government on carbon capture and storage, they're very timely, and I think there is a massive amount of information that can be gleaned from them. What I take away at a very high level is that government for the first time, in my view, is getting very serious about the need to put in place the right kind of fiscal mechanisms to encourage industry to decarbonize, and recognizing that CCUS is going to be inherent to that decarbonization. So whilst those documents are still highlighting a series of options when it comes to ultimately how you pay and generate a fiscal mechanism that can underpin the investments in developing the infrastructure. The fact that we are now talking about a series of options, and those options are all options that are practical, i.e. they're options that have been delivered in other sectors, in other parts of society, gives me great faith that we can get there. However, there's still quite a lot of work to do, and I think government recognize that. The next steps we're expecting, I would expect we should see an energy white paper towards the end of this year, potentially after the next Queen's speech. I think that energy white paper will continue to give us even more definition on how this can be delivered. And then ultimately, I suspect that during the next parliamentary term, we'll start to see regulation written into law. And you have to consider that whilst there are projects moving ahead in the UK and elsewhere in the world, it's very hard for a project to sanction significant investment, investments of the order of hundreds of millions of pounds, if they don't have regulation in place that actually allows them to do that. So, for me, the announcements that came out this week are fantastic. They're a really positive step. we need to go further. We need to pick up the pace. And I'm putting a lot of expectation on the NG white paper that we expect to see before the end of this year.
So do I, Mike, so do I.
Quite keen on exploring a few ideas you've just raised there, Mike. So, I mean, you mentioned cost and pricing, who pays, Luca, you were talking about that. But the options that you're talking about, what are they? I mean, so if I'm a distillery up in, I don't know, Glen Tanner or wherever it is, producing whiskey, what are my options to decarbonize that particular type of business?
No, yeah, very fair example. The food and drink industry is a massive industry within Scotland. It's the distilling industry is a massive export industry for Scotland, and we're working quite a lot with groups like the Scotch Whisky Association to think about these kind of topics. So, using that distillery as an example, and this is a great example of the kind of things that we will try and deliver in our net zero roadmap for industry. But the distillery has multiple options, and indeed pretty much any large industrial emitter has multiple options, and they will probably have to use several of them. And one of the questions that a lot of those emitters have today is, well, where do I start? So let's unpack that distillery question a little bit more. The main options for distilleries is they can switch the fuel that they currently use to hydrogen. A lot of them use natural gas today. That will significantly reduce their emissions, but not completely reduce their emissions. A lot of them already look at various options of bioenergy and waste energy, and they can continue to exploit that further. And that will help, but not completely abate their options. The fermentation process creates a lot of CO2, and that CO2 is actually quite pure, i.e. there aren't an awful lot of contaminants in it. That creates an opportunity for distilleries to potentially look at some of the utilization technologies, which ideally need a pure stream of CO2. And some of those utilization technologies, particularly some of the biological ones, allow us to create things like fertilizer, fish meal, food meal, all of which can be very useful to the same agricultural economy that a lot of these distilleries sit within. And in the case of fertilizer, could be used to fertilize the grain that they ultimately use as a feedstock to create the whiskey in the first place. So, good example of a distillery, and a really useful example of how what we will see for these industries and each and every large emitting site is that there will be a series of options that can be drawn upon. They'll look at hydrogen, they'll look at utilizing, capturing carbon, they'll look at electrification, they'll look at bioenergy solutions, they'll look at greater energy efficiency. And that is a complex question to answer for any individual site. And it's one of the reasons why I think it's fundamentally important for Scotland, but also the other regions in the UK that have a heavy industry, to look at developing these kind of roadmaps that can provide greater insight to precisely those kind of industries.
We haven't touched yet, but it's probably worth mentioning about the oil and gas industry and the role it plays in all of this, right? Because on one hand, the competence and capabilities for the storage part especially sits in the oil and gas industry, the understanding of the reservoir and the various storage location and the fluid dynamics of CO2 or fluid injected into a geological formation. On the other hand, the oil and gas industry has its own emissions, and the current installation in North Sea are responsible for about 18 megaton per year. That's the latest figure I remember, but we're in that ballpark. And the oil and gas industry is working on that direction, try to decarbonize, and could be electrification from shore when possible, integration with offshore renewables when possible, hydrogen, which will have to come from blue hydrogen, especially in the very first part, with therefore requiring CCUS.
And potentially, Luca, what's blue hydrogen? Just for anyone who's not familiar with these terms.
Very, very good. So hydrogen production is of different colors, if you want. The current way of producing hydrogen for chemical use is what is called gray hydrogen, and is mainly from methane, which means that 1/3 becomes hydrogen and 2/3 goes into the atmosphere as CO2, which is very bad. So we need to do a different way to produce that hydrogen we need. The best way is green hydrogen, which is produced from electricity. So we're splitting water into hydrogen and oxygen, and that requires electricity or power. And if that power comes from renewables, then it is green, and it's the best way of doing that. But there's a lot of demand for electricity and more coming up in the next few decades to electrify society. So there's still a gap. Blue hydrogen is another way of producing hydrogen, which is low carbon. It's not totally zero, but it's very low, which is basically from methane, but the CO2 is captured and then stored or reused when possible. And so that's a way where the oil and gas industry can play a big part because of the knowledge and ability to deal with the gas, production of and treatment of methane, and transport and inject CO2 in permanent storage locations. And so I was saying, the oil and gas industry can decarbonize itself and its emission as well. It is an industrial sector that needs decarbonization, and hydrogen CCUS can be a significant part of it.
One of the criticisms that I've read in preparation for this conversation, Mike, is that if you look at I guess the green lobby, there are many voices in that lobby who say that CCS as a technology is unproven. And you mentioned earlier on that there are good examples of CCS out there. So I wonder if you could just give us a sense of where we are in terms of our ability to actually build a CCS business here in the UK. And Is it proven technology, or do we have to do more to develop it?
No, I'm happy to talk about that. And yes, I mean, there's fierce debate over CCUS in environmental circles. There are bodies like the World Wildlife Fund that are supportive. There are, and indeed COP is supportive. There are other bodies that aren't. That question over, it's unproven. Well, for other applications, as I've already discussed, to enhance the recovery of hydrocarbons, to abate emissions from coal-fired power stations, these things have been happening across the globe for 50 years. And those technologies are highly mature, highly developed, very well proven. But they come at a cost. So I don't see that this, in terms of developing CCUS for industry today, technology isn't necessarily an issue. But I do think we should have a wider conversation about how technology can help. So I don't think that this is a technology issue. And indeed, technologies in and of themselves are neither positive or negative. It's about how the technology is deployed. So personally, I think deploying CCUS technology to enhance the recovery of hydrocarbons or to abate coal-fired power stations, it's not particularly positive in the long term. Using those same technologies to allow us to continue to produce cements and aggregates that allow us to build the buildings that we need, the schools that we need, the hospitals that we need. Using that same technology to allow us to generate the chemical feedstocks that go into our pharmaceuticals and medicines, that's a very positive application of the very same technology.
Scale, you mentioned scale. So it seems to me that if we're going to produce industrial quantities of blue hydrogen, you're going to have industrial quantities of the ability to store the CO2 byproduct. So if you scale up, does that not make it a much more expensive proposition as well? I'm just keen to explore the relationship between scaling up CCS and the cost of CCS.
Not necessarily. I think the most sectors, as they grow, as they build scale, their cost of deployment reduces rapidly. I've got a background in both oil and gas, but also in offshore wind, and offshore wind is a fantastic example. The very early offshore wind farms in the UK, you were looking at the cost of electricity in excess of £100 per megawatt hour. You're now looking at less than £40 per megawatt hour. And that has come by effectively building a larger scale business, yeah, a more efficient supply chain, a more efficient use of the technologies, making those technologies more energy efficient, making them more versatile, making them cheaper to produce, more modular so that they can be applied in different scenarios, and ultimately more scalable. So yeah, my expectation and my personal experience in other sectors is that as you increase the amount of CO2 that is captured and stored, the costs per ton of CO2 will go down. And that's proven from other projects elsewhere in the world when this has been done.
Okay. So if you're scaling up...
And we did a study about that economy of scales and economy of skills, going down for the roadmap that Mike mentioned before. I think an important element there, and touching about technology, is it does happen that cost reduction when you scale up and when you increase the production is not a given. It's important how you do it. If you look at the renewable industry or offshore wind, it's naturally happening if you want, because you are producing a big number of totally identical structure, or wind turbines with wind blade and etc. Carbon capture and storage has an element of storage which is dependent on the reservoir. And the reservoirs are different one from another, as every oil and gas person will tell you. But we need to focus on the modularity of the carbon capture element, technology element, because that's where the economy of scale, if you build a lot of membranes of the same type or the same size, if you build a lot of pieces of equipment, and then the assembly is different depending on the contingency of the storage location or the capture the plant that you're going to capture it from, then you can have that customization based on building blocks that are actually produced at a big scale. That's how the cost can go down, and that's where focus on the technology innovation should be on in the first years. How do we reduce the cost? Because technology is there. We can do carbon capture, as Matt said, but the faster we can reduce the cost, the more we can make it competitive for industry to be able to do it and increase the pace of it.
Okay, so let's examine scale a little bit more. Right now, we don't have CCUS at any scale in the UK. Is that not?
No, it's happening at sort of at what I call a demonstrator scale.
Okay.
For this to be impactful, we need across the UK to be, well, we'd like to set a target. Working with government, there's been a proposal that we set a target that by 2030, we are capturing 10 million tons of CO2 per year using CCUS. To put that into context, the total industry emissions in Scotland is about 11.5 million tons. So 10 million tons is a significant contribution to the emissions of the nation as a whole.
So that's in 10 years. In 10 years, we'll be hopefully capturing 10 million tons of CO2.
That's a target. It's a target that I think is achievable, particularly as there are multiple parts of the country working on this right now. There are at least 6 industrial clusters, of which Scotland is one, looking to try and deliver this. There are multiple projects moving forward. There are multiple solutions in terms of how you transport and store the carbon, where you capture the carbon from. So I think that that's achievable. It's not without challenge. And it's also not that different from the pace and scale of change that we've seen in other industries like solar and wind.
Solar and wind have produced, well, wind in particular produced quite a high growth in jobs as a result of its growth lately. So do you see CCS as an industry producing some high value quantity of jobs as well?
Yeah, I do. And I think and this actually speaks to one of the natural strengths that Scotland has. Scotland has a fantastic supply chain that is ready-made to support the CCUS industry, because it is already using and deploying the majority of those same technologies, whether it's for the oil and gas sector, whether it's for the power sector, whether it's for other heavy industries. That supply chain is there. It is largely recognized as world-class. It has demonstrated that it can develop and deploy technologies at scale. And, I think the oil and gas supply chain in and of itself in Scotland is something like 20,000 people. Mm-hmm. That's a significant employer.
And adding to that, we do have the supply chain. We also do have the natural advantage of storage locations. Depleted reservoir, oil and gas that can be reused for CCS. And we know them because we have the subsurface knowledge through the oil and gas industry, plus the infrastructure. So there are pipelines that can be reused both offshore and onshore. And actually, I think another report that came out this week from BASE was about the reuse of oil and gas infrastructure for CCUS and hydrogen and for the transition in general. So Scotland has, I think, a big opportunity.
Yeah, it does. I agree with Luca. I mean, Scotland across the whole of Europe is probably one of the best locations for CCUS. Luca's and I've mentioned some of those opportunities. Along with Norway, it probably has the largest potential to store CO2 in reservoirs that, thanks to the 50 years or so of exploration for oil and gas, have been very well defined. We have a significant amount of infrastructure that can be reused for this. We've already mentioned the supply chain. The other thing that Scotland has is you actually look at where a lot of the industrial sites are, and indeed this has been identified in the roadmap that I've mentioned already. We can quite quickly see, 80% of the industrial emissions are actually in a relatively geographically constrained area, more or less along the east coast of Scotland from Lothian up to Aberdeen. And, that geographic proximity is an advantage because in other parts of Europe, the industrial emissions are spread over a very large area and are therefore far harder to capture. And then there are softer opportunities and softer benefits that Scotland has that aren't always thought about in this context. One of the reasons I'm doing this for Scotland, and you'll notice I don't have a Scottish burr, is that Scotland is one of the few places in the world, in fact, probably unique in this regard, in that it has established a Just Transition Commission to look precisely at how the climate emergency and the energy transition can be done in a way where communities are preserved. We don't push more people into fuel poverty. The overall wealth and happiness of society, can be preserved, and the industry is preserved. And the rich legacy and the rich heritage that those industries have in local communities are preserved. And for me, that's a really important factor for why I think Scotland is very well placed to succeed here. And there's one more I'll maybe mention, which came from some of my own prior experiences. Prior to this job, I spent an awful lot of time in Denmark. Denmark is I think recognized globally now as a country that has probably done more in the last 20 years to transition itself towards renewable and green energy. That wasn't a given. And I've spent quite a bit of time thinking about some of the reasons why that might have happened. And for me, one of the really important reasons is, Denmark, it's a nation of 5 million people. It's a relatively small nation. It's a nation where, actually organizations can quite quickly come together and work with government to make real progressive change. And I think about some of those facets and look at Scotland, which is also a nation of about 5 million people, which also is quite geographically, small on a global scale, and has a tradition of government and industry and society working very closely together, and a rich history of innovation. So, I think Scotland is really well prepared and really well focused to deliver on CCUS.
So if you had to put your money on where the first CCS project is going to kick off then in Scotland, where would it be?
For me, the very first project, largely because it's the most mature today, is the project that is being developed up at St. Fergus. That is looking at, it's called the Acorn project. It has a fantastic group of partners moving that forward, and Nexus is cheering them on from the sidelines. And, it is a project that is looking at taking advantage of some of those scale issues that we talked about, in that it will start by capturing the emissions that happen at the gas plant at St. Fergus. And today that gas plant is the location where over a third of our natural gas is landed in the UK. So there are significant emissions at that plant itself. It's going to capture those emissions. It's going to transport those emissions to a reservoir that has been very well defined and is licensed for the storage of CO2 and is fairly unique in that regard, and start to store that CO2. And from that, it's then going to scale up to start to generate hydrogen and capture the CO2 that's produced in the generation of that hydrogen. And ultimately, it's going to link into other large industrial emitters across Scotland and start to provide a service to transport and store their CO2.
And from that, we should also think about the possibility to expand, and the capacity for storage under Scotland or UK waters, if you want, is bigger, and it can accommodate a lot of European emissions. So I think that there's a question that we have a lot of potential, a lot of advantages, but the others are not sleeping on it. And so Norway is going ahead with the Northern Lights projects and others. So England, we're talking about Scotland here, but from a UK perspective, but talking from a Scotland perspective, there are projects in England as well. So do you see that, Mike, as a competition for storage of CO2 from industrial country in Europe, or from a cooperation, or both? And what barriers are likely to be there? I know that there's a challenge in transporting CO2 from one country to another one, and that will not be made any easier by Brexit, whatever shape or form it will take. So what do you see happening from an international trade or market for CO2 from industrial CO2?
So I guess, multifaceted question, Luca. I think, and I don't necessarily see this as being a competition. I think that if you step back and you look at the industrial emissions that are just from the 7 countries that face directly onto the North Sea, the industrial emissions from those 7 countries are over 440 million tons of CO2 per year. There is not competition for storing that when you think about that is the volume of emissions that potentially have to be stored for Europe to achieve its objective of reaching net zero. So I don't see this as a competition. In fact, I see that there will be the need for a large number of CO2 stores to be developed across the North Sea. In the Norwegian sector of the North Sea, in the Scottish sector of the North Sea, the English sector, the Danish sector, they will all look to develop these things. And by doing that collectively and collaboratively, they can share learnings, they can share costs, it can be done in a more efficient manner. And I think that's the real prize. And we're already seeing it. I think the Norwegians should be applauded for sharing a vast amount of information about what they're doing with the Northern Lights project. There's active collaboration between the Acorn project in Scotland that I just mentioned and Northern Lights. There's active collaboration between the Acorn project in Scotland and other UK projects happening in Teesside, Humberside, Merseyside and South Wales. So I don't see this as a competition. In terms of the barriers, you're absolutely right. There are significant issues that need to be addressed for us to be addressing that 440 million tons of industrial emissions across the 7 North Sea facing countries. First and foremost, we need to put a large number of stores in place. There is no lack of storage potential, but we need to have multiple stores. If you talk to a very large industrial emitter, a multinational heavy industry conglomerate, they will tell you that they need multiple stores available to them. They are not simply going to tie into a single store. They will probably have one store as their preferred option, but if that option isn't available for any reason, they need multiple options. So that kind of resilience that we can build into the CO2 storage industry will come from multiple storage sites. The other one that you addressed yourself, Luca, is the ability to ship CO2 at scale across countries and across boundaries. 2 clear options there. We can do it via ship, and we can do it via pipeline. Ultimately, pipeline is more expensive up front, but potentially cheaper longer term. There are multiple interconnector pipelines between the UK and Europe. They're pretty heavily used today, but it proves that they can be done. So the pipeline option is definitely feasible, but it's expensive. I suspect what will happen first and foremost is the shipping of CO2. And there, people start to question whether that's feasible. The technology already exists. We ship vast amounts of products that have been liquefied from a gas to a liquid to reduce their volume in Europe all the time. And the volumes that we're talking about here aren't that different from the kind of volumes of liquefied petroleum gas, LPG, that are already transported around Europe. So, I think shipping will come first. I think that can enable potentially the options in the future for dedicated pipelines cross boundaries to transport CO2.
I'd like to bring it back to COP. So next year, COP's in Glasgow. Let's say I'm talking to someone on the street in Glasgow, a man in the street, women in the street. We're talking about COP and the impact of climate change in Scotland. I get a few questions about CCS. So I reckon what they're going to ask me is a few simple questions. If we do CCS, will it make my energy more expensive?
It's largely going to be focused on making the products that you use every day as readily available as they've always been.
Will it make my products more expensive?
It might make your products a little bit more expensive. Ultimately, somebody has to pay for this. And either the manufacturer pays for it, in which case they will pass on those costs to the consumer. That's just basic economics. Or the government pays for it, in which case, some way, form or other, those costs are passed on to us as society and taxpayers.
Will it add jobs to the Scottish economy?
Yes. And more fundamentally, it will protect vast number of jobs that already exist in the Scottish economy. Scotland is an industrial nation, and it's rightly proud of that industrial heritage. And without being able to get industry to be decarbonized, we can't necessarily expect those industries to continue. And those industries create basic products that we need every day. So this will create jobs, but I think much more importantly, it will protect vast numbers of jobs across Scotland.
And will it be safe? If you're pumping huge quantities of CO2 into a reservoir, how can you guarantee it's going to stay there?
Well, first and foremost, transporting the CO2. CO2 is effectively an inert gas. It's what most fire extinguishers use to put out fires. So in that regard, it is inherently safe. Society has grown very used and comfortable with the fact that we transport natural gas across the nation each and every day. And this is far, far safer in that regard in terms of its combustibility. And then when you come to the question of storing it, yes, this has been done for over 50 years. And the work has been done, and the basic science is there to demonstrate that in a lot of cases, the CO2 that you put into the ground over, we're looking at 50 to 100 years, it turns into rock itself. A lot of the rocks that we stand on in this country are what we refer to as carbonates. Carbonates are basically CO2.
And doing all of this, will it make an impact on climate change? I mean, a real tangible impact on climate change?
Yes. I firmly believe this is fundamentally important. It's not the only thing we have to do, but as I mentioned at the outset, if industry is 40% of our energy demand and a quarter of our CO2 emissions, and we really don't have other options at scale other than carbon capture, this is going to make a massive difference.
I agree, and I think we shouldn't see that CCS as the way to fight climate change. Is one of the piece of the jigsaw. an important one, but not, we need to do all the other things. We need to do the energy transition. So energy needs to transition to renewables. We need to move toward the circular economy and reusing, be better reusing everything we do and produce from plastics, but any other materials as well. CCUS is also part of the solution. So it's not a license to keep doing what we're doing. It is part of the solution to transition to that. I would add that in the long term, CCS will reduce its impact and importance in fighting climate change, because we will develop a more and more sustainable way of producing cement, steel, and decarbonized heating, etc. But as a transition technology in the next 4, maybe 5 decades, it is crucial, because it allows also renewables to grow up to produce electricity instead of in that sense, it is an enabler, because it accelerates the transition. And one thing we haven't touched upon is direct air capture, which is, if you want, a different type of CCS, because it's not capturing from an industrial production or from an industrial emitter, but it is taken straight from the air or from the sea, if you want. So taking the CO2 from the environmental system and storing it down, which again, it is being argued in some places as a potential license to keep polluting, and it's not. It is another way of accelerating the reduction of the quantity of CO2 in the atmosphere, which is growing at a dramatic and concerning level. So that's another technology which is very, very interesting and starting development, very expensive, which leads us to the point of innovation. Technology innovation is needed, and is needed both to accelerate the rate of normal, call it normal, CCUS, and also direct air capture, but also for the utilization element, the U that you mentioned before, the use of CO2 for fertilizer or feedstock, or for farming and other usage, which is still in the kind of low to medium readiness or low to medium proof, as opposed to CO2 for permanent storage, which is well proven.
Well, that's a great way to kind of sum up things as well, Luca, because we've almost run out of time. What I've learned today is that CCUS is a huge topic. There are lots of components to it, and it's complex, and it's diverse in application, from oil and gas offshore to a distillery somewhere in the Highlands. Food and drink businesses will be massive in this space. Mike, you've really explained it very, very sort of clearly to my mind. I wish Nexus very well, all the best in its efforts, and Godspeed in getting up to 10 million tons of CO2 by 2030, captured and stored. So yeah, I don't know. Luca, do you want to say anything to close off? All I can say is thank you.
Thank you very much. I really enjoyed the conversation, and as you said, there's a lot to do and a lot to discover in CCS, and hopefully we will do that in the next few years.
Thank you, guys. Really stimulating debate. Appreciate the thanks. We're going to need all the support that we can get to help deliver this. But I'm passionate that this is necessary, and it's also incredibly timely. This can be delivered relatively quickly at scale, and amongst the other options that we have to fight the climate emergency, we need to pull every lever that we can that can ultimately deliver at scale quickly, because that's where we are today.
Okay, thanks, Mike.
Thanks a lot.
Thank you.